Welcome to Photonics In Focus, the podcast where industry leaders and innovators share insights into the latest advancements in integrated photonics technology. Join us as we explore how this emerging technology is transforming industries and driving new possibilities, and how AIM Photonics is at the forefront of this revolution. Tune in to stay ahead of the curve in the rapidly evolving world of photonics.
Welcome, everyone. I'm Gayathri Jampana, Program Manager at AIM Photonics, and today we are talking about AIM Photonics' recently released Assembly Design Kit and what it means for photonics design and packaging workflows. I'm joined by Amit Dikshit, Design Enablement Manager, Chris Striemer, Director of Test Assembly and Packaging Operations, and Basanth Jagannathan, AIM Photonics Design Enablement Engineer, who led much of the ADK development. Thank you all for being here. AIM Photonics recently announced the release of its first assembly design kit. We'll call it ADK for short. To start with, can you briefly describe the ADK and what it does?
So Gayatri, I'll jump in. And ADK, like you observed, it stands for Assembly Design Kit. And terminology itself is not new in the industry. In the electronic industry, ever since, I would say 2010, this assembly design kit concept was popularized because packaging was getting very complex. Now, if you come to the photonics world now, which is what we are in, similarly, the revolution is really happening in the packaging space. So what we want to have is a framework, a design framework. So it's a software design framework through which the system designers can seamlessly and without friction adopt our test and packaging offerings while they're designing their PIC chips so that the whole thing is consistent. So in essence, Assembly Design Kit offers the designers tools that they can design into, and we ensure by our assembly design kits that they will be compliant with the process needs of our packaging offering.
Thank you, Bas.
And just to add to that, people are more familiar with process design kit in the process world and think of the assembly design kit as the equivalent of PDK or process design kit in the assembly and packaging processing world.
And obviously there's a very practical aspect to this in that it forces the designer to start thinking about system level, not just worrying about the properties of the one PIC, photonic integrated circuit chip that they're working on. And so designer benefits by that knowledge, that educational aspect, and ultimately the performance and the speed with which we'll be able to turn around a package, for them. TAC, in its assembly process, also benefits by having it be a much higher quality relationship, higher level relationship, so that we're looking at standardized designs coming in that we can very, very easily interface to. And that's important.
I think that Chris brings up a very good point, which is that designers, when they're designing a PIC chip, in their mind, they have a desire to have it packaged. But a desire is different from an action. And when they don't think about the action up front, and then towards the end, they say, hey, Chris, can you package this? Then their PIC chip is really not configured at that point to be packaged. So what we are trying to do is to move the whole exercise up front so that the designer can think about this aspect of packaging and its constraints. It has constraints in the way you have to do the PIC chip so that everything is compliant.
Typically in the design phase, what we find is the earlier you are the design, the more that packaging is an afterthought. And what ends up happening is that diminishes the value of each turn of your design flow and your fabrication. And so there's tremendous value to be thinking about these things up.
Just to build up on what Chris and Basanth said, I think I like this part where I think Chris, you mentioned about system level thinking. And in the CMOS world, that is quite prevalent, where people start thinking about systems. And with the recent announcements by NVIDIA and TSMC, I think we are also seeing that in the photonics world also, people are starting to think at the system level. So the ADK that we are working on, I think we are in the right time at the right place there.
Can you give us a sense of what you were seeing in actual projects at AIM Photonics that led to the development of the ADK?
So the ADK that we have released, before the ADK was available to our community, people were largely relying on best practices or guideline documents to design their packaging solution. But the analogy that I have is, it is like driving without a GPS to an unknown place. But with an ADK, they will be able to use these tangible software tools to ensure that their design and their packaging solution is compliant with our assembly and packaging process at that. So we are really solving this problem where designers are able to use tools that will speak to their design and make sure that they will be assembled with first-time right design.
There is also another aspect here which I find very interesting, which is that if you look at the optical packaging space, and Chris can jump in anytime in this, is that the solutions are very rich, and that those set of rich solutions are being combined with equally a set of rich solutions in the electronic packaging world. For example, the photonic chips that we make today, I think, are not the same caliber of integration as things were in 1980s. We have even moved past fiber attach and wire bond to our chips. We're talking about flip chips, we're talking about interposers, we're talking about micro lenses, we're talking about lasers being on the same platform. So the complexity and innovation has just exploded, and our offerings have exploded in this space. And so, there are two aspects to the ADK. One is to sort of standardize our offering and say that, these are the things that we as AIM Photonics are offering in addition to the MPW service. And the second thing is to sort of introduce the designer to the world of options, not on some Excel spreadsheets or PowerPoints, but truly as tangible electronic collaterals that they can use to simulate and experience, how a thing, a packaged solution may look like even before they get into it.
And I would also comment that designers are smart people, right? So they aren't deliberately missing the importance of packaging downstream and the importance of the system. But what they do miss is they make an assumption that standardized packages that are plug and play off the shelf can just simply absorb their chip into it and it can become a product for them. And that's just not the way the packaging world works. As Basanth was talking about, there is a richness, a very wide range of solutions that are out there available, technologies that are out there available, and demands that are out there that force us to have multiple forms of packaging. And so, one of the values certainly that the ADK will bring is it will seamlessly integrate the advances that we make at TAP for what we're moving toward, which is standardized packages, having a couple of key offerings that make it easy in the prototyping phase for our customers to get a result that's usable, and so they can get as much data, information, feedback, use as possible out of each turn of their design and each chip that they make and get packaged.
The ADK has been described as bringing packaging considerations into the design workflow. What does that actually look like in practice for a designer?
So maybe I'll jump into this. So, when we say a system designer, they're sort of working in a design platform or let's call it an electronic design automation software, which in our case becomes an electronic photonic design automation software. And it's not one software. It's a whole bunch of tools, designed for the designer to create their photonic chip with all its components in place, right? So the ADK, what it provides to them is tools with which they can do physical design, like layout. And these are template-based so that they don't have to struggle to figure out how to sort of place each of the entities. We provide them with these templates that they can drop in. And furthermore, they can do the optical simulation with our models and within the framework of optical simulation tools to see how much loss is there in the system and whether they can tolerate it or they need some other configuration. And in addition to both electronic and optical simulation capabilities, what we also want them to have a sense of is through 3D models as to how these things will fit in their system. Because at the end of the day, these are packaged, they're in a housing, they have a certain physical structure that we are offering, and it behooves the designer to see how it fits into their sort of arrangement that they have for their system.
So isn't there like an interesting aspect to this, that you're going from a PDK that's largely a two-dimensional world, right, on a chip, to now we're entering into a three-dimensional real space world. The idea of, okay, now we're worrying about size and airspace and how does it fit into the bigger box, bigger system? What are the heights that are on a PCB or however the system's going to be arranged? And so I don't know, could you comment a little bit on how you envision getting some of that visual information, that three-dimensional aspect, that sort of information and design space conveyed to, designers that are interested in our ADK?
Yes, so there are two elements that we are looking to support within the ADK, especially for translating what is done in the 2D in the PDK, as you mentioned, to the third dimension here. One is we are providing solid models where you can get, which Basanth earlier alluded to, which gives you a physical representation of how the assembly looks like. And from the discussions that we have had so far, fiber attach is usually an issue, right? There are a lot of considerations there, depending on the type of assembly you have, whether it's wire bond, whether it's interposer base, or whether you are flipping a electronic IC onto a PIC. The fiber attach tolerances, how that sits within the PCB. So those are important considerations there. So the solid models give you visual feedback and will guide your tolerances and the geometries there. The other aspect is support for simulations. And Basanth earlier mentioned optical simulations. So users can take advantage of the various parameters that we mentioned in our documentation and use it in their simulation framework to obtain realistic results from what losses they can expect, what performance they can expect from their assembly. There is a third element that we are also looking to support, which is support for RF simulations using real 3D geometries, but that is planned for 2026.
I think this is one point I'll address, Chris, in this question. I think it's very interesting, is that, if you look at traditional electronic packaging, people talk about 3D integration, people talk about 2.5D integration, right? The infrastructure or the design toolings are beginning to bring in the 2.5D representation. And the 2.5D representation, what it essentially means is a fast rendering with low overheads of what is essentially a three-dimensional structure. Right? But if you compare those length scales to what we have in the photonics world of optical packaging, I think the length scales are very, very different. And the housings that they sit in are also very different. So we really have to provide a three-dimensional true scale model. And to what Amit was saying, the full 3D modeling, and by the way, the automation tools are also catching up to this. There are great automation tools today that can provide seamless 3D model into which you bring in finite element meshing and do, the thermal simulations, do the RF simulations at a large scale. So I think that's I see as a big difference between the world of EDA and the world of EPDA.
In the physical aspect of packaging and installing chips into packages and attaching fiber arrays, one of the biggest surprises that a lot of our customers have is how small that PIC is relative to the fiber array. Suddenly it's, where is my PIC in this package? Because it's such a small part of it, but it has the disproportionate amount of time and effort that goes into that particular part. And I think a lot of times it's not until they actually see that physical result, that three-dimensional, in your hand sort of example, that people appreciate that. And another aspect of one part of the reason I'm a little bit fascinated by that two-dimensional to three-dimensional transition is because, most people assume that the difficulty of lining up a fiber array to a PIC or putting a laser aligned to a waveguide or an edge coupler, is lining up the two-dimensional. How do you get that robot to have it perfectly aligned because you know what your GDS looks like and you know where it needs to go? Interestingly, it's usually the Z direction. It's the third dimension that's most difficult because that's the dimension you don't see as easily. And that's the dimension that you're really relying on the PIC and the structures and your design to fix for you. And usually that can take several design iterations just to optimize that one aspect of it. So, there's no diminishing the importance of looking at 3 dimensions as early as possible, in the design flow.
To your point about people getting surprised about how big the fiber array is, because of the unique customer base that we have here at AIM Photonics, where we work with a lot of startups, with academics and with the government labs, we frequently have customers whose core expertise is PIC design. They are in a situation where they submit their PICs to us and say, here is the PIC. Now you worry about assembly, you worry about packaging, you worry about fiber attach. And I think that's where the ADK will really be useful. So it will help them also gain expertise into the assembly and packaging world there.
Amit and Basanth, can you please walk us through what's included in the current release and how those pieces work together?
Okay, so I'll jump in first. So the current release, it's structured into the following components or following, let's say, release directories. The one part deals with the layout of the PIC itself so that it's compliant with the packaging. And here, we are supporting all the major electronic design automation vendors in this space, so that we don't want the system designers to pick a particular software. So we are offering it in all the softwares that they are normally used to. And then the second part is dealing with the fiber attach. So we are providing characterized models of the fiber attach that we're doing. And we're also providing solid models so that they can envision how the PIC will look relative to this fiber attach. The third part is that we're offering a board where, things can be wired out for both DC and RF testing alongside placing the fiber. And the final thing is the whole assembly. We are providing a solid model for the whole assembly so that the user can see how this option can fit into their system. And while these all sound in a way very rigid sort of offerings, what they are like they're templates. And if the user feels like something has to be changed, we are fully open to working with them to sort of tweak the thing to suit their application or needs.
They're templates, though, to an existing physical analog.
That's right.
And so it's really important to understand that there's something at the end of the road. There's something that you're designing toward. There's something that your physical chip will attach to.
Yeah, and users, if they download our assembly design kit, they'll see a folder structure in which all of the elements that Basanth spoke to are arranged. And one of the tasks that we really want to also accomplish through this exercise is to standardize the contents of the ADK, what the ADK looks like. So in the PDK world, if a user downloads a PDK from any foundry or for a given platform, the folder structure and the contents have been standardized to a large extent. And that is missing in the ADK world. So that is also one of our exercises here.
How should a designer think about using templates versus simulation models in the ADK?
Yeah, I would say that, they go hand in glove. The templates are, like Chris mentioned, at the end of the day, they represent a physical solution or a path to a physical solution. And what a template does is it takes away the pain from a designer to figure out the various combinations. We're saying that if you follow this template, you don't even have to simulate because we have done that work for you and we are providing you that data for how, for instance, a fiber attached to our edge coupler within our solution, what loss it entails. You don't have, as a designer, they might spend a lot of time trying to figure this out. We're saying, no, we are providing you a template that sort of captures all that behavior. And if you follow it, you will get a loss that we have already modeled for you. And similarly, we're saying that, in the template, you can place, be it RF pads or DC pads in a certain fashion, and they would be correct by construction for wire bonding. And the whole thing is sort of enabling the designer from get-go not to worry about, where would the optical inputs be, where would the electrical inputs or outputs be. That template kind of fixes everything in place for them. So it sort of saves them time. And at the end of the day, by the way, to the point of standardization, it also helps us because there are not a multitude of variables that a designer is trying and presenting to us to manufacture.
And to add to that, the templates are not fixed templates. So what we also offer within the layout environment is a parametric cell, a P cell, and people in the CMOS community and in the PIC community are familiar with this terminology, the parametric cell or a P cell. And that provides various options for the user to lay out their PIC and also make sure that it is compatible with our assembly process. The library which contains the templates in the P cell also sits conveniently within the user's PDK environment. So that is another convenient feature that we offer.
One thing that can sometimes be unclear with new tools is what's available today versus what's still evolving. How should users think about the current release?
I'll jump into that. First thing is that we don't want users to be either confused or worried. So we are meeting them with our design enablement in the software of their choice. So we know the ones that are very popular. And there are examples like people like, let's say, open source tools like K-Layout for their design work, or maybe GDS Factory, or maybe more traditional EDA tools like Cadence. We are supporting all of them. And our templates, we are providing to seamlessly work in all those environments. So hopefully there's no surprise for the designer in the sense of the tool offerings that we are capturing.
And what is supported right now that designers can download right away is support for wire bonds and for fiber attach. So if there is a situation where a PIC and an electronic circuit sits on a substrate like a PCB, and they are connected through wire bonds and traces, and then there is fiber attached to the PIC, that is currently supported. And what we are looking to support in the future is more complex assemblies, including flip chip and interposer-based assemblies.
A question to Chris. Since the ADK was just released, people haven't had much time to use it yet. From your perspective, how do you expect this to change how customers engage with TAP?
Well, hopefully the discussion to this point has made it obvious that this will simplify the interactions with the customer coming to TAP, because TAP can have the expectation that designs coming in are going to match our requirements. And we know that the customers coming in will have realistic expectations and will have designs that, we can produce a favorable result with, and ultimately have the shortest turnaround time possible and allow us to help more customers, because we're not spending so much time with each individual customer tackling the challenges that are associated with designs that haven't anticipated the requirements for the packaging. So in general, it's a win-win, I think, for both our customers and partners, as well as for the team at TAP. And we look forward to, all these successful outcomes that will result, especially as the ADK matures and includes some of the offerings that we're adding at TAP.
Chris, maybe one comment here that you can expand upon is, the need for standardization in the world of optical communication and optical links and fiber attach and so on and so on. What's your perspective on that, given that we are seeing an explosive set of solutions that are there?
Yeah, I think there's an explosive set of solutions, but at the same time, they're all coming back to physical designs, right? You have your edge couplers, you have grading couplers, you have different variations of each. You have, permanent connections, you now have detachables in this world of CPO. And I don't think any one facility can handle all of these different attachment technologies, because many of them are tied to specific tools. And so in addition to having standardized packages, established expectations and specs, part of the ADK basically makes sure that there's compatibility with the tooling, that we have as well. And, there's opportunities to interact with TAP staff ahead of time to ask questions about the different aspects of this, because they may find, a designer may find that, through their simulation, there is a more efficient way of potentially doing something. But what they haven't anticipated is that there's difficulty associated with complexity on the packaging side. We may not have the equipment, or it may be relying on a technology that really isn't optimized yet or available. And so I think that that aspect of it comes through and is fairly well resolved by the ADK.
For someone who is designing a PIC with AIM Photonics today, what's the most immediate benefit they would see from using an ADK?
So our overall goal is to, of course, get first-time right design. That is the goal. I think the most immediate benefit that they will see is we hope at least that they'll spend less time on thinking about their assembly and packaging solutions. That is the immediate benefit that they should see. But longer term, our hope is to get first-time right design.
What I would say is that the photonic designers right now, today, as they are downloading the PDK from GitLab, they need not talk to anybody. They know exactly what is our TAP offering for that particular ADK, and they can size their solutions with respect to that. And then, of course, they can have a much richer and nuanced dialogue with both us on the AIM side, TAP, to see, if there's something better that's needed. I think the key thing is that it's a frictionless entry into the world of packaging right from the get-go.
And I agree, fewer design iterations. You're designing into a system that works, that's known to work, that people have developed a path for. And that's always, you're basically starting, several steps ahead. You can think of it as for each customer.
Basanth, let me ask you this question here. From a technical perspective, where do you see the maximum benefit for designers? In which area of the assembly? Fiber attached, wire bond, flip chip, micro lenses? What is one area where customers will benefit the most from a technical perspective?
What I feel is that what the customers will benefit most is to just see the offerings that we have and sort of design into it and be first time right in that design. And through our offering, whether it be for the fiber attach and wire bond or, things that are coming soon with flip chip and micro lenses, it just exposes them to the design considerations right from get-go that they can see visually and through the simulations or through the package of data that we are providing as to how it'll impact their system level performance. So that's the greatest benefit I see for them. This is an entry into the world of packaging, which lowers the risk for the designers. It provides them with tools to do easier designs. And overall, it gives them a very good picture from get-go of what they need to do.
I think in some ways you could almost say that from several aspects, TAP or your packaging vendor may benefit more than the customer itself, because, even though AIM Photonics works on a best efforts basis, we do the best we can, we do a lot to make sure that a customer can get their data out. And when they have a design that looks great in 2 dimensions, but when you're looking in 3 dimensions, things are overlapping. When things overlap in 3 dimensions, that is a big problem for TAP. And it makes it very difficult for us to come up with solutions that allow the customer to get the kind of information they need and not waste that spin and that turn in the design phase. And so not having to go through all those, Herculean sort of approaches to be able to do that is a large benefit both to the customer as well as the TAP.
As photonic systems continue to evolve, we are hearing more about chip packaging co-design. Where do you see this going, and what role do tools like the ADK play?
Yeah, I'll jump into that. I think you're absolutely right. The days, even if you look at the electronics world today, right, the days of CMOS scaling, as was described by Moore's law, is essentially dead. And what has replaced it is, I would call it packaging advancement. And what that has led to is the world of disaggregation, meaning that everything that you thought once upon a time that you could integrate on chip has become more valuable to integrate it on package. Now, when you are integrating a disaggregated set of components onto a package, and that's where the integration lies, you basically need the electronic design tools to do the end-to-end simulation, and that's what is implied by the word co-design. And here in our world of AIM, we have the yet another vector, which is the optical piece. So the richness that we have in terms of the physics spans from electronics to optics to the packaging solutions. So at the end of the day, for what the system designer needs, there is really a need for doing co-simulation. And we recognize that in the ADK. And interestingly, this is a tough problem. And it's a tough problem that the industry doesn't have a turnkey solution. And that's where our opportunity also lies, in that we are thinking about how to structure these multi-physics problems, how to bring in the right tools, and how to have a cockpit through which we can operate, or the designer can operate these to get their system level answer.
I will close with one question for each of you. What's one thing you want designers to understand about the ADK?
I would say that silicon photonics technology is quite mainstream now from what we have seen with all of the recent announcements. The technology for large revenue applications like datacom, telecom, or even AI to some extent is available there. But packaging in the photonics world remains a bottleneck. And that's why I think, to just emphasize the point earlier, designers have to have packaging considerations right when they start their design cycle. And that's where the ADK really helps them. So the ADK is meant to address the photonic packaging bottleneck that we are currently seeing.
That question takes me back to something I'd read a long time ago in the context of process design kits, or PDKs, which, were invented or conceived of in, I think, the 1980s, and now are like so prevalent. The point from the creators of the PDK was that a PDK can certainly not make you a great designer, but what the PDK can do is to avoid all the pitfalls that are there in a design as you're designing into a foundry. And I think that comment, or that sort of thought, carries well into our ADKs as well. At the end of the day, we are providing a solution that captures our packaging technologies. So it is providing the designers with all the tools that they would need to design into what AIM TAP are offering. While it may not make you a great designer, it certainly will avoid all the pitfalls of designs that are potentially there.
And I guess the one thing I would convey to a designer is the fact that this ADK is not just about connectivity to the outside world in the form of data, but the fact that you're getting three-dimensional representation, system-level information, is also a conveyance of your own ideas to the outside world, right? So if you're interacting with investors, if you're interacting with the rest of your team, if you're interacting with your own customers, if you're interacting with marketing, suddenly you're producing things that are more convincing, easier to explain, and I think ultimately make the entire development flow, more efficient, especially to those in the private sector looking to, create the next generation of silicon photonic devices.
Thank you, Chris. Thank you, Basanth, and also Amit. Thank you all for joining.
Thanks for joining us on Photonics In Focus. Be sure to subscribe and stay tuned for more deep dives into the latest advancements with industry experts throughout the integrated photonics ecosystem. For more information about AIM Photonics and the work we're doing to advance the integrated photonics industry in the United States, visit our website at aimphotonics.com.